So here we're going to go through a directory for the project from Cardano's Catalyst, Decentralized AI in Drug Development. So basically these directories are containerized, lightweight, but fully reproducible containerizations of some of the milestones for Fund 8's project Decentralized AI in Drug Development. So in this case, everything is run locally in Docker containers or in multi-containerized environments, but quite simplified for this demo. So we're mostly running on CPUs just to make things fast and basically avoid some hidden dependencies, but more or less similar or the same containers. It can also be scheduled on NuNet or other cloud resources with little change. And eventually, we'll be able to run these decentralized AI drug development protocols on Cardano. So basically, the first milestone asks us to prove whether we can train a property prediction model and generate data on basically a single node. So here we're going to basically work with machine learning models. So we can go to the directory, and we can basically run Docker compose on this directory. I'll make the code available as well, so you can look at this code, which is basically some Python files and Docker containers, so it can be run for you guys too. And basically it sets it up, and in this case what we're doing is running but basically multi-GPU, or in this case multi-containerized versions, which for instance if we run on NuNet can be run on multiple GPUs, but essentially create two workers that might for instance be running on two nodes, and we have some neural network that we for instance train, and then we have some action node that we do some aggregation on this. So basically this is a lightweight example of what we might do if we have, for instance, trying to orchestrate something that uses different data shards, and the master then in some mastered node then basically does some aggregation over this. And so here we're basically just doing this with two different containerizations. But again, this can be run different NuNet nodes as well. We can look at other ones, for instance. So here, what we're doing is we're showing that we can run on different heterogeneous data resources. So here we're and again, this is a very simplified case just for this demo, but basically we have two basically mismatched feature sets, and then a third container waits and basically merges these feature sets together into basically a table, a CSV file table, and basically retrains it. And basically the point is that basically that we can incorporate these different types of data integrations into its into these pipelines by running these containerized versions on either NuNet or other cloud resources. And so what we can also do is look at some of the other things we have. So for instance, we can also look at basically how to run privacy preserving inference for whatever data sets we might have. And basically in this case, what we're doing is we have some privacy cell that blinds the input with basically some random scalar, and basically encrypts it. And this is just a simple case, but essentially we can do similar and more complex encryption schemes if we want. And basically, yeah, we basically encrypt the input between the server and the client. Yeah, we show how this is possible. So basically, if we wanted to do this on a larger scale without NUNet, then yeah, it'd be basically this. And we have is basically have a API, but in this case, we can just go directly to how we might deploy this. And for instance, we'll do the exact same thing, but essentially we use Flask, and yeah, basically allows us to host this API. And in this case, I'm hosting it locally, but it would be quite similar if you want to do it in other ways. And then yeah, we can basically create an API with these types of hosting. So either on NUNet or, for instance, even other decentralized marketplaces. And yeah, so basically we don't, what we're showing is basically working containerized building blocks, but the next steps are basically straightforward. We push these, or actually the more complex, less demo-y images to a registry, write a NUNet job spec, and attach a Cardano smart contract that releases ADA when a worker submits a verified model update or inference. So everything you're watching is eventually going to be open source and already tagged. But yeah, essentially, basically moving from the laptop to more decentralized marketplaces is still an operational task. But yeah, thank you for this opportunity, and we can show you, we'll share the code, and yeah. We also have these Hedgehog tokenomics paper where we discuss like decentralized simulation, validation, for instance, and also the economic model. We go over staking mechanisms. Usage fees and marketplace dynamics, inflation rewards, supply and distribution, as well as other things like ecosystem partnerships and incorporations,